purpose of this video is to illustrate teaching practices that can support students' engagement in data investigations. I'm Stephanie Casey.
And I'm Holly Lynn Lee. We use the data investigation process framework to guide our teaching and research in statistics and data science education. Investigations include framing the problem and posing questions, considering and gathering appropriate data, processing the data so it is organized in useful ways, visualizing and exploring different statistical measures to look for patterns or relationships, considering the assumptions and limitations of certain models, and then communicating results in a way that are appropriate for an audience and could result in future actions. In this video, we're going to illustrate how a teacher creates an investigative opportunity for her high school students and how a student is supported by the teacher's use of these purposeful practices in each of the phases during their investigation. As we do this, I'll play the role of the student who is investigating the data.
And I'll provide commentary from the teacher's perspective. So in this classroom scenario, a high school mathematics teacher has recently learned that her school district is looking to purchase vehicles for their driver's education program. This seems like a great opportunity for her students to do a data investigation. They could advise the district regarding which type of vehicle they should buy as a result. This provides a way for the teacher to use a curricular activity that is relevant to her students, providing them an opportunity to have a voice and a decision in their school community. She thinks that making a data-driven argument to the school district seems like a great way for students to apply their learning and make a difference in their community context. Also, her high school students are just at the age where they're starting to drive, so they are getting more interested in vehicles themselves. The teacher launches the activity by explaining the end goal to the students, to advise the school district on what vehicles to buy for their driver education program. She gives them personal agency by inviting them to independently engage in the data investigation and make decisions about the factors they consider as important in the decision. She expects her students to be fully capable and engaged. The activity is also designed to build on students' prior knowledge of statistical concepts, as well as concepts they've learned in other classes, such as science or social studies. So let's go on and see how a student engages in it.
I really like that I can suggest to the school district what they need to consider when buying vehicles for driver's ed. I care how much money gets spent on gas, but I also care about choosing vehicles that are better for the environment. So carbon dioxide emissions are going to matter too. A quick Google search on fuel costs for new cars leads me to a few different websites. After looking at a few of them, I remember that my mom used the official EPA website to look up information about a car that she wanted to buy. I see a place there that I could download data about all vehicles made in a year. I had to use the fuel guide to understand more about how they measured and reported different attributes about the vehicles.
The teacher notices the student looking at the emissions information in the guide, so she asks them if they learned about carbon dioxide emissions in their science class. The student replies yes, so they go on to have a conversation about what the student learned about vehicle emissions impact on the environment and how that information could be used as justification to prioritize purchasing vehicles with low emissions.
So I took the downloaded data in a CSV file and I opened it up in a spreadsheet. I see that each vehicle is in its own row and there are a lot of columns for each thing measured. And look, there's a Ferrari and a Corvette. There are some columns with missing data and attributes I'm not sure I really need, so I'm going to filter my data to hide those columns. I'm also going to import the data in CODAP since we've been using that in class. Once I get the data in CODAP, I do some additional organization. I grouped the data by division name and I reordered the columns. I'd like to first look at the city and highway gas mileage. My mom told me that our car gets better gas mileage on the highway. I'd like to see if that's true for most vehicles. I made a scatter plot of city and highway fuel efficiency. It definitely looks like vehicles that kind of stink on mileage in the city also get low mileage on the highway. And those that are better in the city are better on the highway. There are a lot less points on the right that get better than like 30 miles per gallon, and they don't seem to be in line with that big cloud of points that I see. And that point way up in the right corner is a Prius. I hear those are great cars for using less gas. I decided to add a linear regression model, and that R squared value tells me that this is a pretty decent relationship. For that bunch of points on the left, the model seems to work since there are points that are kind of above and below the line. But I am concerned about all those scattered points above 30 miles per gallon that are all below the line. By clicking on those points, I noticed that they were hybrids. Well, I don't really know much about hybrids, so I asked Chanel to tell me about her family's car. She told me that they get great gas mileage, but that their car is really a lot better on gas when they drive in the city than when they go on long trips. But that even on a highway, they get much better mileage than their non-hybrid car.
The teacher was pleased to see the student go back to the frame a problem phase, including reaching out to their classmate to find out more about hybrid cars. She's glad to see that her classroom environment, built on practices where students often work in small groups and rely on the expertise of one another, was beneficial during this activity as well.
All right, well, I decided that I wanted to categorize all the vehicles in my data set into whether they are hybrid or not. So I used a formula to transform the attribute model type into a new attribute called hybrid that just simply told me yes, it was a hybrid, or no, it was not. It actually took me quite a while to write that formula. Then I overlaid that attribute hybrid, and I could see that those vehicles in the upper right were indeed all hybrids. I made a new graph to separate the points into two different scatter plots. Both models have a high R squared, but they are different. The slope of the hybrid line was less than 1, while the other vehicle's line had a slope more than 1. So yeah, this backed up what I had learned before about hybrids getting better mileage in the city than on the highway, which is reverse of the other vehicles. And I like that because most people drive their cars a lot more in the city than they do on the highway, and certainly in driver's ed. So I think our district should also really care about lowering emissions. I overlaid the combined CO2 onto my scatter plot. This helped me see that vehicles that are shown in darker red don't get good gas mileage and have higher CO2 emissions. I noticed some hybrids also have high CO2 and low gas mileage. That was actually kind of surprising. I think we should focus on vehicles that have higher gas mileage with lower emissions.
As the students in her class prepared to communicate and propose action based on their data investigation, the teacher advises them to come to a clear recommendation for the district regarding factors to prioritize, as well as which vehicles to purchase for driver's education. She encourages them to keep their audience of school administrators in mind when crafting their argument and communication strategies, but to let their passion be evident. She knows that communicating with adults can be daunting for some high schoolers, but has high expectations that hers are capable and she will work with them to prepare them for success.
All right, so I really want to recommend that the school district consider those vehicles that get better than 30 miles per gallon in the city and have lower CO2. So I highlighted those in the graph. And then I filtered the data set to only include those 41 vehicles. Some are hybrid and some are not. I ordered the vehicles so that the lowest annual fuel cost was at the top of the list, and that one is a Prius. I plan to give this list of vehicles to the district along with a report of my analysis. I recommend they look more into the purchase price and maybe maintenance costs to inform their decision.
In this illustration, we explored how using the data investigation process helps us teach statistics and data science in ways that support all students. The process allows students to ask their own questions, explore areas of data that interest them, and take ownership of their learning. The teacher used a few key teaching practices as well to design a learning experience that's relevant to students, encourages them to explore areas of a topic they care about, and create space for collaboration for peers. The final share out allows them to share their voices in a meaningful way.
This is what teaching statistics and data science looks like, creating opportunities for all students to be empowered with data and make a difference.